If you compute lift and After you compute lift and drag, you would use these values to calculate your drag and lift coefficient. So our contours, they are pretty standard. We have velocity contour, static pressure contour, dynamic pressure, and total pressure contours. If we look at our static pressure contour, you can see that our static pressure is highest when at the stagnation point. And if you look at our dynamic pressure, it should be inverse, which it is, minus the wake region, which is characterized by low pressure and low velocity. So both those values are going to be lower. So for this lab, we need to show our velocity vectors. So we go down to vectors, velocity, and scale down the actual size of our vectors, because if they were too big, you can't really see what's going on. So after you scale it down, we can see all these vectors with some circulation going on the wake region, which is made through an adverse pressure gradient because of the wake region. Pretty standard. That's what we're looking for. And another thing that we're asked to find is the streamlines. So we go down to path lines, click particle variables, particle ID with the steps of 2000. You can play around those numbers just to see which is the best, so we can see how exactly our 10-degree flat plate disturbs the flow, which is a lot more than a vertical plate, which is a lot more than a horizontal plate would do. But that's everything.